Chapter 5, Video 6 is on finding the slope or finding the rate. And we're going to talk about how those are often interchangeable terms. Okay, so I can find the slope or the rate from a table, graph, equation, and I often abbreviate equation EQN, but that's equation, or story problem. And we're going to look at all of those today. Okay, so for our vocab, we kind of already mentioned it, rate and slope and what they call a constant of proportionality. Proportional, and then proportionality. There we go. It's a big, long, and ugly word, but proportionality. You're going to see me use those, all of them, kind of interchangeably. If it's proportional, we can find the rate, we can find the slope, and it has a constant of proportionality that we can also find. So just be aware that all three of those kind of mean the same thing in this section for us today. So we're going to talk about how to tell if it's proportional, and then how do I get the rate or the slope or that constant of proportionality in each of these different situations. So graphs, how do I tell if it's proportional? Got to have two things. A graph is proportional if it is a straight line. So when I'm looking at the graph, if it goes in a straight line, and if it goes through the point 0, 0. Okay, that point on a graph 0, 0 is called the origin. So if it goes through the origin. Now, what does this really mean? Well, if it has a straight line, that means it has a constant rate. Things that have a constant rate are going to be, when I graph them, a straight line, right? And it has a starting value of 0. So it goes through this point 0, 0 because it starts at 0. So it is going to be proportional if it starts at 0 and has a constant rate, so it shows up as a straight line. Okay? Well, how do I find the rate or the slope or the constant of proportionality from a proportional graph? You would take any of these points, right? There's points all along here. Maybe they're labeled, maybe they're not. But you could take any of these points on that graph, and remember our points are always x, comma, y, right? We have an x coordinate, we have a y coordinate. And if they label them here on the graph, x, comma, y, I could take any of those points, and if it's proportional, then I'm simply going to take those x and y values and do y divided by x and divide. So let's look at some examples of that. Turn the page. Here we go. First, I want to see if it is proportional. So this is a straight line, and it goes through the point 0, 0. So yes, this is proportional. And if it's proportional, I can find the rate, slope, constant of proportionality by doing, remember this is, if you need to label them again, x, comma, y. So y over x would be 4 over 1. Here's my y value. Here's my x value. And simplify that, I just get 4. So this one has a rate or a slope of 4. Okay, is it proportional? Yes, it's a straight line. It goes through 0, 0. So yes. And I can do y over x. So I'm going to take this y over this x. And that is my rate or my slope. 3/2. Is this proportional? It's a straight line, but notice it does not go through 0, 0. So no, it's not proportional, and I'm not going to worry about how to find that slope. Okay, so you might also have questions that say, interpret the slope. All right, well that means I have some labels here, and I'm going to have to actually label or explain what my slope means. So this is a straight line. It goes through 0, 0, so it is proportional, which means I can find the slope. Now I can pick any of these dots to use. So I'm just going to pick this one right here. The x value is 1. The y value is 2. Right? This is x, this is y. So over 1 up 2 gives me the point 1, 2. And if I find my slope, y over x, 2 over 1. And I need to label those. Well, the label on the x is hours. And the label on the y is miles. So if I interpret that or tell you what the slope means, it is saying that I walk 2 miles, and remember we say per hour. So 2 miles per hour. And my equation then would be y equals 2x, 2 miles times every hour that I walk. Let's try another one. Straight line through 0, 0, so this is proportional, which means I can find the slope or the rate, y over x. I'm going to take this y, 7.5, over this x, 100. Doesn't matter. I could have used these numbers as well, but it would divide to the same thing or simplify to the same thing. And now I'm actually going to divide that. Y divided by x gives me, okay, and I need to label that. Well, the label on the x is miles. The label on the y is dollars. So if it's $7.50 for 100 miles, then that means it comes out to 0.075 per mile. And that's my interpreting the slope. Basically, when they ask you to interpret, it just means label. Put the units on there. All right, well, the equation here would be, if this is my rate, y equals 0.075x. That's it. All right, let's do one more. I have, looks like this is going to be the easiest point to use. These points all kind of go through somewhere in the middle, so I'm not sure exactly where they are, but I can tell this one is at 5, 40. So it's a straight line through 0, 0. Let's find the rate. Y over x. Y is 40, that looks like pounds, but I'll just change this to dollars to make more sense. $40 for 5 kilograms. And if I actually divide that, I get 8, but I need to label it, $8 per kilogram of cheese. And I can put that into an equation. Y equals 8x. 8 is my rate or my slope. Okay? Let's keep going. Is it proportional? If I'm looking at a table, how do I know? Well, check all the ratios. We did this already in this chapter. You need to check all the ratios and make sure they're equal, or check all the easy arrows and make sure they match, right? So, times 2.5, times 2.5, times 2.5, times 2.5. If you can see those easy arrows in your head, great. If not, you're finding all of these ratios and simplifying it. Find this ratio or fraction and simplify it, or divide. Simplify or divide and check to make sure those are all the same. Okay, if they are, your answer is yes. And again, to get the rate or the slope, y over x. Okay, usually your tables will be labeled with an x and a y. If it's not, then usually the first one is x, the second one is y. First one is x, second one is y. X, y. So once you check and figure out if it is proportional, you're going to do y over x. So 25 miles over 10 millimeters on the map. Okay, 2.5 miles per millimeter would be my rate or my slope. If these all come out to be the same arrow or the same ratio when I divide them, then my answer is yes. And to get the rate, I would do y over x. So I think here I get yes, checking all of these, it is proportional. And 250 over 2 pounds, comes out to $1.25 per pound. And that would be my rate or my slope for the whole thing. So you have more tables here. I want you to pause and practice checking all of these ratios. If I look at all of these ratios, do they all come out the same? If yes, then just take one of those and stack y over x and make sure you can find the rate. Okay, so pause and finish these here. Okay, hopefully you paused. I checked all of these ratios. Yes, so I stacked y over x and got 45 words per minute for each one. I could also turn that into the equation y equals 45x. Or here, yes, they all give me the same ratio, 32.5 miles per gallon. We're going to turn the page, and for the sake of time, we're going to skip those tables, but you could come back to those and do them the same way and talk about equations. So how do I tell if it's proportional? Well, the starting value has to be 0, and it has to be just some number, the rate or the slope, or that constant of proportionality, or sometimes your book or whatever worksheet will put in m or k, or that constant of proportionality, right? All of those different terms go there times the x. So how do I find the rate? It is just the coefficient on the variable, or the number in front of the variable, the number multiplied by the variable. So these are pretty simple. If I give you the equation y equals 4x, 4 is the rate, 8 is the rate, 0.25 is the rate, 3 is the rate, negative 2.7 is the rate. It could be positive, it could be negative, it could be a fraction, it could be a decimal. So let's practice writing the equation. If I tell you the rate is 7, y equals 7x. If I tell you the slope is negative 9, y equals negative 9 with an x. If I tell you the constant of proportionality is 4.3, y equals 4.3x. Okay, remember rate, slope, constant of proportionality are interchangeable. All right, we're going to get as far as we can on story problems here. Story problems, again, has to start at 0. Starting value is 0, and it has a constant rate of change, or slope, right? It's going up or down the same each time. So let's look at a couple examples. In these story problems, we need our rate to be constant, or the same the whole time. So all the rates should have labels, and that include the word per. Here we go. If pizzas cost $14 each, well, my rate would be $14 per pizza, and my equation y equals 14x. $11 for each ticket. My rate would be $11 per ticket, and my equation would be y equals 11x. I'm just taking that rate or that slope or that constant and putting it into my equation here with the x. All right, 27 pieces of candy for 9 people. Well, I'm going to have to actually do that. 27 pieces divided by 9 people, and that comes out to 3 pieces per person. There's my rate or my slope with a label, and then my equation, well, just plug that 3 in, y equals 3x. Okay, so you have 3 left. I want you to find the rate with a label, and then plug it into your equation, y equals, plug that rate in with an x. So finish the last 3 now. All right, 108 leaves over 6 hours, 18 leaves per hour, y equals 18x. 17 inches over 5 days, 3.4 inches per day, y equals 3.4x. $56 over 7 hours, everything's labeled, $8 per hour, so y equals 8x. Okay, so rates have labels, and slopes have labels, and then you can plug that number right into your equation. All right, that's video 6.